A uniform light slender beam AB of section modulus EI is pinned by a frictionless joint A to the ground and supported by a light inextensible cable CB to hang a weight W as shown. If the maximum value of W to avoid buckling of the beam AB is obtained as beta pi square EI, where pi is the ratio of circumference to diameter of the circle, then the value of beta is. This is quite an interesting question, guys. This tests the student's ability to engineering mechanics and mechanics of materials. Let's look at the solution. Let us first start the solution by constructing the free body diagram at joint B. This is what we get. We have a weight W acting vertically downwards. Let us assume that the force in the member AB is acting towards left from joint B and the force BC acts in the direction shown at an angle theta is equal to 30 degrees. Now, considering this free body diagram, let us consider the conditions of equilibrium and let us use summation forces along y direction, that is summation of forces in the vertical direction are equal to 0. We get FBC sin 30 is equal to W. From that, we get FBC is equal to 2W. Similarly, for the equilibrium, let us consider summation of forces in x direction as 0. So we get FAB plus FBC cos 30 is equal to 0. From that, we get FAB is equal to minus root 3 into W. Now, there is an important note point here. We get the value of force FAB as negative of root 3 into W. That means the direction considered initially in the constructing free body diagram should be reversed. The corrected free body diagram at joint B looks this way. It can be observed that the direction of force FAB is reversed based on the magnitude. We know that critical buckling load for a column is given as PCR is equal to pi square EI by L square, where length of the column, that is length of the beam AB, is given in the question as 2.5 meters, which can be observed from the figure. For the beam AB to buckle, force FAB is responsible. Therefore, the critical buckling load will be FAB is equal to pi square EI by 2.5 whole square, where FAB was found out as square root of 3 into W is equal to pi square EI by 2.5 whole square. By sending root 3 to the right hand side, we get W is equal to pi square EI by root 3 into 2.5 whole square, where I can write it as beta into pi square EI, where beta is taken as 1 by under root 3 into 2.5 whole square. Upon simplification, we get beta as 0.092 per meter square. Therefore, the correct answer to this question is option A.